It's my great pleasure to welcome you as the new ISPRS president here. I think we're attending a very interesting, a very exciting Congress. Lots of participants, many interesting discussions, broad fields being covered. Of course, photogrammetry as important as remote sensing and also spatial information science. In ISPRS, in the last 4 years, we've started to initiate some changes with respect to the structure of the society. I suppose we're already seeing good results stemming from those changes, and we need to continue to bring this forward, certainly in the areas of computer vision, in the areas of exploiting constellations of satellite imagery, and certainly also in areas like big data or crowdsourcing and parallel computing, to just name a few. One particular issue certainly is putting our work into context with social media and also with other areas of the social sciences around the more technical issues. And I think there is some work needed also, in particular to involve more scientists from Latin America and from Africa. And finally, we have initiated more intensive collaboration with the commercial sector.
So Earth Engine is a petabyte scale archive of satellite imagery hosted on Google infrastructure. And on top of that is a cloud-based platform for geospatial processing that also runs on Google machines. So the idea of Earth Engine is to not only democratize access to geospatial information, but also to use Google scale technologies to help solve the world's biggest environmental problems that require geospatial information. And so Earth Engine provides an online JavaScript IDE and a Python API as well that allows users to get access to 40+ years of satellite imagery, including MODIS, Landsat, Sentinel, atmosphere and climate data, and really a whole wealth of geospatial information that is essentially siloed for organizations that don't have the capacity to analyze big data, that don't have lots of computers, that don't have lots of hard drives, that don't have the capability to download all that information. So Google stores that information, hosts it on Google machines, provides this IDE with a JavaScript API and a Python API that lets users get access to that information, analyze very big data, and do it all on Google machines without having to use their own computers. So you can do global scale, data-intensive analyses using satellite imagery on a little laptop from the comfort of your neighborhood cafe.
So radar in space is unique. Why that? Because it's the only sensor technology that allows us to have high-resolution images independent on the weather, independent on the cloud, independent on the day and night illumination, as it works always with high resolution. At this time now we are preparing ourselves for the next vision. We have a mission proposed called Tandem L. Consists also of 2 satellites, but working at L-band. And we have a new technology, a new enabling technology that is the digital beamforming. It's the digital antenna that enhances this mapping capability by at least 2 orders of magnitude, so we can map the Earth 100 times faster than what we do with Tandem X. And with that, to monitor these dynamic processes, being the soil moisture or earthquake, volcano eruption, ocean currents. These are things that changes very fast. Also deforestation, glacier melting, and all these things we can do with Tandem L. We can map the whole Earth twice a week. And this is outstanding. With that mission, we hope to make a substantial contribution to solve the societal challenges, and this will be an important step towards our mission or towards our vision of a radar observatory in space.
So I think it's very exciting. Today we are in the age we call the mobile age, and with our smartphone we can actually collecting a lot of information which is invisible and impossible previously. Yeah, with your smartphone we can collect the information about human dynamics, human movements, our communication, our interaction with other people, our relationships. So by analyzing this data, we can get a better understanding about our society and our communities. So I think as a geospatial community, we need to tap into this type of information to improve our understanding about human beings. Pokemon Go is a very exciting opportunity for the geospatial community because underlines the technology is using the GIS or the street map combined with the location-based services and POI and with augmented realities. But it means that our community, we need emphasizing not the traditional information system, but we call it information services. It's emphasizing the user behavior, user experiences. Why Pokemon Go is so popular? Because people like it. Users like the experiences. Why the traditional GIS is not so popular as the Pokemon Go? Because we designed a terrible interface, terrible functions. So this is a lesson we can learn from the Pokemon Go, how to make our audience more enjoy and engage with the information. So I think one of the points for today's presentation is we want to emphasizing that user experiences, user center is a key to success for the GIS applications.